Okay, so I just finished giving you the 40,000 foot view of chapter 12 that we're doing here. Um, and I talked about looking for a pattern and using a line of regression to make predictions. But you need to test the quality of that line of regression to determine whether, even though you have a line of regression, is it good enough that it can be used? Does it pass certain tests? Does it pass a level of confidence? So um, there are these four questions that we're going to be answering in chapter 12 as we go along. So question one is, does there appear to be a linear trend between X and Y, the independent variable and the dependent variable? So the independent variable from the last example was like fat, and the dependent variable was calories, right? Fat we had on the x-axis, calories we had on the y-axis. And so what we do is we create a scatter plot of the data. Scatter plot of, shouldn't be DATS, it should be data. Okay, create a scatter plot of the data and qualitatively evaluate a linear trend. So like what we did at the very beginning is we just created a scatter plot, and just looking at it, does it look like there's a linear trend? That's all that is. And then are there outliers, and should they be removed? Now, this is something that we're not going to cover until the very end, looking for outliers and removing them. But typically, this would be something that you would do at the very beginning. And so an outlier, if we had one in this example, so for example, for fat, you can see that, a majority of the data seems to be along this line here, this linear trend. If we had a data point that was maybe somewhere out here, we would say that's an outlier. And we would go kind of do a statistical test, a mathematical test to clearly identify that as an outlier, and then we could take that data point out of our analysis. But we'd have a mathematical reason, justification for doing so. You just can't take data points out that you don't like. Okay. You need to have a reason as to why you did it, and it has to be mathematically and scientifically sound to do something like that. And you have to be transparent. I this point was outside a certain boundary. Mathematically, it's an outlier, and I have removed it when conducting my future analysis. Okay. So we're not going to cover that until the end because I think kind of getting these other questions nailed are going to be a little more important here in this class. So that's question one. Make a scatter plot. Does it look like there's a trend? Question two is, do you consider the line of regression to be strong, moderate, or a weak estimator of the sample data? So this is if you were just to communicate to someone, hey, I conducted this analysis. I looked at the correlation between fat and calories, and it was very strong. And then I looked at the correlation between sodium and fat, and it was extremely weak. It was very weak. So when you talk to people in terms of very strong, strong, moderate, weak, very weak, that paints a picture in their mind of what that graph looked like, what that scatter plot looked like. And so you can communicate that conversationally. You can convey that message literally by using these words, like strong, moderate, and weak. Okay. But how do you determine whether it's strong, moderate, or weak? And that's what we'll be answering here in question two. So we're going to determine a line of regression from the data, which you saw up above. But something that you didn't see above is we're going to get something called a correlation coefficient. So a correlation coefficient is a value that tells you how strongly one random variable is correlated to another. All right. And then we're going to use that correlation coefficient, which is numerical, and we're going to convert it into a literal translation using a table of correlation coefficient values. So we'll take this numerical correlation coefficient that we calculate, and we'll be putting that into a translation table that'll tell us strong, moderate, or weak. Okay, not too heavy lifting there. Question 3 then is, does the line of regression estimate the sample data with at least a 95% confidence level? Okay, so now this is the point where we try to determine whether the line of regression uh, is a high enough quality, gives us a high enough confidence that we can use it. Just because it exists doesn't mean it's worthy to be used. We need to pass it through kind of like a rigorous test. And if it passes that test, then it can be used. So we're going to determine and compare a correlation coefficient critical value against the correlation coefficient of our sample data. Okay, the correlation coefficient of our sample data is based off of our line of regression. And this correlation coefficient critical value is a boundary value of the correlation coefficient that separates whether our sample correlation coefficient is considered good or bad. Okay, this is where we're going to make kind of like a value judgment here. And if it passes that test, then we need to determine, does the sample line of regression model the population line of regression significantly different than no correlation? So significantly different than a correlation coefficient of 0. And where this came into play in our example up above was in this example here on the right. Because you remember what I said about the slope of the line being close to 0? Well, having a slope of the line of regression close to 0 means that a correlation does not exist. And so that would certainly fail this last question. Sure, we can calculate a line of regression through the data. That's fine. But it fails this last question, this last test, and therefore it's meaningless to use it uh, uh, with our sample data. Okay, it's meaningless to use it. And what we're going to be using is a 95% confidence level. And remember what we've been talking about, where percent probability is equal to area under the curve. And so this 95% is going to be an area under the curve of 0.95, and that's under a normal distribution, something that looks like this. And so this is going to end up creating a confidence interval where we're going to have two values, some lower bound and some upper bound. And if our value lies within the lower bound and upper bound, we're going to consider that a bad estimator. And if it's outside those boundaries, then we're going to consider it good. Something like that. And if our line of regression does pass that test, then we can use it to make predictions. Okay. So we're going to be kind of going through and learning all the things you need to learn about linear regression and correlation. And along the way, learning how to do this kind of analysis to test whether a line of regression is good or not. Okay, and that leads us to section 12.2. So let me know if you have any questions.